Alright, this is day 15 of solving math problems until your whole life member notices me. And here we have a very interesting integral, right? So we want to find the integral of pretty much 1f1 of 1 to x, right? And what is a hypergeometric function? Usually hypergeometric functions pretty much are usually functions that arise in differential equations or pretty much any higher level of math, to put it vaguely. And pretty much the definition, right, of a hypergeometric function, let's say, for example, this one, right, 1f1 of 1 to x. This is pretty much going to be equal to the sum from n is equal to 0 to infinity of 1 n and 2 sub n. These pretty much are rising factorials, right? This is pretty much going to help us understand the fact that we have a fairly weird name for these, right? Which is going to be a Pockhammer factorial, or a Pockhammer symbol. And since we have x, right, it is going to be x to the n over n factorial. So with that in mind, we want to find a, I guess, integral or antiderivative to this hypergeometric function. And we're going to rewrite it using the series definition, right? So pretty much if we just look at x to the n, and we have pretty much the sum as n equals 0 to infinity of Pockhammer of 1 and Pockhammer 2, and then 1 over n factorial. And then the integral from, well, there's no bound, so it'll just be the integral of x to the n dx. This pretty much just becomes x to the n plus 1 over n plus 1. Okay? And the question is, how do we rewrite this as a hypergeometric function? What do we do? Well, let's just know that we have 1 n and 2 sub n is equal to 1 over n plus 1. And pretty much with that, right, we are going to have that it is equal to x times the sum from n equals 0 to infinity of 1 n squared over 2 n squared, and then x to the n factorial. So pretty much now that we found our series, right, we can pretty much rewrite this as the integral, right? So pretty much that is going to be that this is equal to x times 2f2 of 1 comma 1, and then the denominator 2 comma 2, and then finally x, and then plus c. So that is pretty cool, and also a pretty much a cool thing is that this on the right hand side, this hypergeometric function is also equivalent to ei of x minus ln of x. So pretty much that is a exercise for you guys to look into, for all you math enthusiasts. So yeah, that's pretty much it for this problem, and hopefully it was very clear that this wasn't really that bad. It's just about knowing a little bit of calculus with series and the Pockhammer symbols, or rising factorials as they're called. And yeah, this is a very nice and surprisingly easy hypergeometric function to integrate. So yeah, thank you for watching, and bye-bye.